Assalamualaikum and good day to Dr. Yusiza Yusof and everyone. So, we are from Group 6. This is a project for Advanced Theory of Computer Science. The project title is Multi-Tap Turing Machine for Palindrome Condition. Our group members include Teng Junwah and Grace Lee, and lastly myself, Alin Shada binti Muhammad Zamri. Next.
Hi, I'm Teng, member of the Group 6. For this project, my main responsibility is building the multi-tap Turing machine in the simulator and testing the machine using the execution trace to make sure everything is work correctly. So today I will briefly explain how our machine works and demonstrate both an accepted and a rejected input. Our design use two tapes. So the tape 1 store the original input string, while the tape 2 is used to store a reverse copy of the string. The idea is quite simple. If a string is a palindrome, then it should be identical to its reverse. To make the machine easier to manage, we use two special markers, the hash as the start marker and the n as the end marker. So this marker helps the machine identify the boundary of the string during the computation. So now let's look at an accepted example, which is the string ABBA. Okay, the first phase is copying the input. So the first phase happens in the state queue node. So here on the machine scans the tab 1 and copy the input on the tab 2 in reverse order. So as tab 1 move to the right, the tab 2 move to the left. So when tab 1 reads an A, it writes an A on the tab 2, then it continue with the next symbol. This process repeat until the machine reach the end of the input. Once all the symbols have been copied, the machine will place an end marker at the end of the tab 1 and a hash marker at the beginning of the tab 2. So this marker helps to define the boundary for the next phase. So after that, the machine will move from the Q node to the Q1. So under the phase 2 is repositioning the head phase. So in state Q1, the machine needs to prepare for comparison. So the tab 1 heads need to move back to the beginning of the string, while the tab 2 head stay in the position. Think of it resetting the reading position so that the machine can start comparing the original string with its reverse version. So once the tab 1 reach the start marker, the machine move into the state Q2. Okay. So in state Q2 is a phase 3, is comparing the strings stage. So this is the most important phase. The machine now compares the symbols on both tabs one by one. So now the A match with the A, B match with the B, B match with the B, and A match with the A. So since every symbols match successfully, the machine continue moving forward. So now there's no mismatch is found. Eventually the machine reach the end marker on tab 1. So at this point, it transitions into the accept stage, which is the Q3. The machine stop and accept the string, so we can conclude that the ABBA is a palindrome. So another example is a rejected example. Now let's try a string that should be rejected. We use the hash ABAB. So the machine performs the same copying and positioning step as before. So however, during the comparison, phase, the very first comparison already failed. So the tab 1 reached the A and while the tab 2 reached the B. So because these symbols are different, the machine immediately transition into Q4 reject. So the competition is stopped and the string is rejected. From this execution trace, we can see that the machine successfully distinguished between the palindrome and the non-palindrome strings. The accepted input reached the accept state, while the rejected input reached the reject state. So this confirms that our multi-tap Turing machine behave correctly according to the language definition. So thank you for your attention.
Hello and good day to you, Doctor and everyone. So today I will explain the formal mathematical model of our two-tape Turing machine. So the machine is represented using a seven tuple. So M is equal to Q, sigma, gamma, delta, Q0, B, and F. Where each component defines a part of the machine. So first, Q represents the set of the states. So our machine has five states. So we start with Q0, Q1, Q2, Q3 as accepting, and Q4 as rejection. So the input alphabet, which is sigma, contain the symbols A and B, which are the only input symbols our machine process. So the tape alphabet gamma contains A, B, sharp, hashtag, and N. So here, hashtag act as a start marker, while N represents the end marker on tape 2. So the blank symbol B is represented by the empty space symbol, and the final state set F only contains Q3, which is accepting. Meaning the machine accept when it reach this state. So now I will explain the function of each state. So in state Q0, the machine copies the input string from tape 1 to tape 2. However, because of the tape 2 head moves in the opposite direction, the string is stored in reverse order. After copying process is complete, the machine moves to state Q1. So in this state, tape 1 moves back toward the beginning of the input, while tape 2 remains positioned for comparison. So next, in state Q2, the machine compares the symbols from both tapes simultaneously. If the symbol match, they are erased and the machine continues moving forward. So if all symbols match until the end marker is reached, the machine enters Q3 acceptance and accepts the input. So however, if a mismatch occurs, such as comparing A with B or B with A, the machine moves to a Q4 rejection and rejects the input. So the transition function defines these movements. For example, in Q0, when the machine reads an A, it writes A on tape 2 and moves the head accordingly. Similar rules apply for symbol B. Overall, this tape 2 Turing machine works by copying, reversing, and comparing the input string. It accepts strings that satisfy the required condition and rejects strings that do not. So that's all from me. Thank you.
I'm Grace. So for my part, I will explain the digital architectures and state diagram for our multi-tape Turing machine for palindrome reconnaissance. My sections focus on how the machine is designed and how the state work in JFlag. Our machine used two tapes. Tape 1 store the original input string, while tape 2 is used as auxiliary memory. During the copy phase, symbol from tape 1 are copied onto tape 2 in reverse order. The symbol N mark the end of the input of tape 1, while hashtag is used as the boundary marker on tape 2. These architectures allows the machines to compare the original inputs with its reverse versions. So this is the state diagram built in JFlag. The machine starts at Q0s where it copies the input from tape 1 to tape 2 in reverse order. Then it moves to Q1 where the tape 1 head is moved back to the starting positions. After that, the machines enter Q2 where both tapes are compared symbol by symbol. If all symbols match, the machines reach Q3 and accept the input. If any mismatch is found, it moves to Q4 and rejects the inputs. The transition functions define how the machines reads, write, move, and change states. In Q0, the machines copy the input. In Q1, it repositions the head of tape 1. In Q2, both tapes are compared. Matching symbols are erased and the machines continue comparing. If the machine reaches the end marker N, after all matches, it goes Q3 and accept. If there is a mismatch, it go to Q4 and rejects. This prepare the flow for sub 3 part where the execution trace will show the exact step-by-step running of the machine. This slide summarizes the memory operations using the input ABBA. In phase 1, Q0 copy the input from tape 1 to tape 2. Tape 1 keeps the original input while tape 2 store the reverse copy. At the end of input N is written on tape 1 and hashtag is written on tape 2. So in phase 2, Q1 rewinds the tape 1 head back to the left boundary, while tape 2 stay at the boundary marker. So this prepare both tapes for comparisons. So in phase 3, Q2 compares both tapes symbol by symbol. For ABBA, the comparisons are A equals A, B equals B, B equals B, and A equals A. Since all symbols match, the machines reach the end marker N. Finally, in phase 4, the machines enter Q3 and accept the input. In any mismatch happens during comparisons, the machines will enter Q4 and reject the inputs. This memory operation summaries prepares the audience for the details execution traced in sub 3. That's all for my part. Thank you.
So that's all from our group. Thank you so much. Bye bye. So that's all from our group. Thank you so much. Bye bye. So that's all from our group. Thank you so much. Bye bye.